Alright, this video will help you with these things called exponent laws. This is part 1 of 2 because there are a whole bunch of laws. But today I want you to learn 2 of them. The law for products and the law for quotients. So let's take a look together. Okay? When we multiply, my question is, does the order matter? So if I did 2 times 3 times 4, is that the same thing as 4 times 3 times 2? Or is that the same thing as 3 times 2 times 4? And I hope you are going to say they all produce the same answer, so therefore does order matter? No. And this will help us discover some of the exponent laws. So I'd like you to look at the first table here and talk about products of powers. And I'd like you to rewrite these as repeated multiplication and then see if you can simplify it into one single power. So 7 to the power 5. If you wrote down 5 of these 7s, I'm happy. And then that 7 to the power 3, that's another 3. And so I got 7 times 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 7. How many 7s do we have? Did you say 8? I like it. Now do the same thing with the other 2 lines, okay? And let's see what you get. 10 times 10 times 10 times 10. And then 10 squared is just 10 times 10. And it looks like there are 6 of them, so 10 to the power of 6. And then here we have negative 2 times negative 2 times negative 2. And then we've got one of these factors of negative 2. There are 4 of them in total, so negative 2 to the power of 4. So now I'd like you to just look at this and that. What do you see? What's the connection in terms of multiplying powers with the same base? So what do we do with the exponents? This one is 8, the next row here is 6, the next one is 4. Can you see what happened? Can you see that all we did was we add the exponents? And so this actually comes to the exponent law. So the exponent law for products or multiplication of powers is this: as long as the bases are the same, in this case they're both a, and our exponents are m and n, all we need to do is we keep the exponent as is, but we keep the base as is, but we add the exponents together. M plus n. That's it. So let's try these examples. Write the following as a single power. I have 5 to the power 2, and I have 5 to the power 11. Yes, the base is the same, so we'll just write down the 5, and all we need to do is just add the 2 and the 11, or 5 to the power 13. Okay? Similarly for the next one, the base is the same, so we'll just keep it as negative 3. And 9 plus 16, that's just 25. That's it. And then for part C, don't freak out if there are more than 2 things multiplied together. It's the same idea. We just keep adding them together. So in this case, the base is the same. We add 3 plus 7. And whoa. What's the exponent for this? Just 6 by itself? Is it nothing? No, it's actually 1. This is the same thing as 6 to the power of 1. So don't forget to add on 1. So this is 6 to the power of 11. That's it. Okay. So you try example number 2. I'd like you to not just write as a single power, but evaluate. So write it as a single power first, and then evaluating just means give me the standard form answer or the number. So for part A, 2 squared times 2 cubed, I see the 2 is the same as the base. 2 plus 3 is 5, and 2 to the power 5, I believe, is 32. Here we go, we have negative 3 to the power 3, and then once again there's no exponent, so that's like the number 1, so 3 plus 1 is 4. This means I'm multiplying negative 3 by itself 4 times. Negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. And then negative 27 times negative 3 is negative 81. Right? Wrong. Remember, this is negative 3, negative 3, negative 3, negative 3. I have an even number of negative signs. That's right. This is not negative 81. It's just positive or regular 81. Cool. Don't get tricked. Part C, 4 cubed times 5 squared. Well, the bases are not the same. Uh-oh, not the same base. So can we write it as a single power? The answer is no way. We can't do that. So what do? We just have to evaluate. So go ahead and calculate 4 cubed, then calculate 5 squared, and then multiply them together. So 4 cubed is 64. 5 cubed is 25, and then you just have to multiply this together. That's, I think, 1600. So notice in part C, the bases, once again, are not the same. We can't combine them together. Okay? Now, we just talked about the exponent law for multiplying. Let's talk about an exponent law for dividing. So we call dividing quotients. So now I'm going to ask you to do 7 to the power of 5 divided by 7 to the power of 3. And I'd like you to write this once again as repeated multiplication. So 7 to the power of 5 on the top, or the numerator. We're going to divide that by 7 to the power of 3 on the bottom. There are 3 of them. And then notice when you're dividing the same things, this just divides out. That becomes 1, that's 1, that's 1. So we're just left with 7 times 7, or 7 squared. Okay. Do the same thing for the other ones, and let's see what lovely rule or law you can come up with for quotients. Goodbye, 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 goodbye. So you're left with 4 of them. 10 to the power of 4. Negative 2. Negative 2. Negative 2 all over negative 2 times negative 2. And you're just left with negative 2 to the power of 1. Okay, notice I put a bracket around the negative 2 because it's the entire thing. That's my base. So notice once again, when dividing powers of the same base, compare, oops, I should highlight, compare, compare, compare. What do we do with the exponents? Yeah, we subtract them. So here's the exponent law for quotients. When the base is the same, in this case it's a, we then subtract the exponents, m minus n. Okay, those are the 2 laws for today. So let's apply them. Turn the page. Okay, write the following single power. So now we're doing division. And with division, we subtract the exponents as long as the bases are the same. So in this case, both of them are a base of 5, so I can keep them as is. 20 minus 16 is 4. 5 to the power of 4. We're done. Okay. Same thing with the next one. The base is the same. That's good. 9 take away 4. That's 5. We're done. And then here, once again, don't freak out when there's 3 things. Same idea. 10 minus 7. And then once again, this is 6 to the power of 1. So 10 minus 7 minus 1. 10 minus 7 is 3. Minus 1 is 2. This is 6 squared. That's it. All right. Now, let's combine everything together. And let's also throw in some order of operations. Oh, no. It's getting hard fast. But that's okay. Because as long as you understand these ideas, you can do them too. Remember, the laws only work when the bases are the same. So let's take a look at 4a. Negative 3 to the power 4 times negative 3 to the power 6 divided by negative 3 to the power 8. Are the bases the same? And the answer is yes. So then I see multiplication division. Do that from left to right in terms of bed mass. So in this case, let's combine this first. That's negative 3. And 4 and 6, I guess that's 10. And then we still have our negative 3 to the power 8. Now we can do the division. The bases are still the same, so 10 minus 8 is 2. Ta-da! We are done. But if I ask you to evaluate, I want you to have the final number. So negative 3 squared, that's 9. So my advice is when you evaluate, always try to write it as a single power or simplify first, and then evaluate at the end. Now, you might be thinking, Mr. Lee, couldn't I just done it all together? Couldn't I have just written down this? Negative 3, 4 plus 6 minus 8. In this case, yes, you can, and you'll still get the same answer. All right? All right, part B, same thing. You can try this on your own. I think you can do it. Division, multiplication. Let's do division first. Bases are the same. That's great. So 6 minus 5 is 1. And this is a 7. Without an exponent, of course, that's just 7 to the power of 1 as well. So 7 to the power of 1 times 7 to the power of 1, that's 7. 1 plus 1 is 2. And that's, of course, 7 squared, or 49. Okay. Part C, notice this is a fraction. So when there's a fraction, it's like there's implied brackets. It's like the brackets are hidden. there's a bracket that does the entire numerator, and there's a bracket that does the entire denominator. So when you see a fraction like this, always simplify the numerator first, then simplify the denominator next, and then do the division last. So in this case, if I were to do the numerator first, I see multiplication. 6 to the power of 9 times 6 to the power of 5. Both of them have the same base of 6. So I add them. 9 plus 5, 14. Once again, I'm now simplifying the denominator. So 3 and 8, that's 11. And now my final step is do the division. And of course, that means I subtract the exponents. And that's just 6 to the power of 3. Or the final number is 216. Okay? All right, two more. D. D has a lot of stuff. I see exponents, multiplication, subtraction, addition. So once again, let's do the exponents first if you want to. But in this case, I'm going to ask you to see if you can simplify. Can you simplify things first by making single powers? Okay. Can we do that first in any part of part D? And I say yes we can, because I've got this part here and I've also got this part here. Notice the actual bases are different, but I can still combine the bases here, because the multiplication here, the base is the same. The multiplication here, that base is the same. So 4 to the power of 3 times 4 squared, that's just 4 to the power of 5. Okay? And then 2 to the power of 5 times 2 to the power of 3, that's just 2 to the power of 8. And this is now plus 2 squared. Are you asking me, Mr. Lee, how come we didn't combine this one as well? Is there a law for adding bases? The answer is no, only multiplying. So that's why I only did that part. Okay? At this point in time, you really can't do much more in terms of simplifying, so let's just go ahead and evaluate. So 4 to the power of 5, I think that's 1024. 2 to the power 8, double check my answer on your calculator, but I think it's 256, and this is just plus 4. So 1024 minus 256 plus 4. 1024 minus 256 plus 4, 772. Okay. And for part E, I'd like you to do the same thing then. See if you can simplify first. And I'm thinking, oh yeah, I can do this. Now once again, don't include this minus 3 as well, because, hey, there is no law for subtracting exponents. There's only a law that allows you to simplify when you're dividing them. And that law says we should subtract the exponent. So 5 squared, or sorry, 5 minus 2, that's just 3. So that's 3 to the power of 3. Okay, we're going to keep this minus 3 squared. And then we got this big doozy over here. So, remember, implied brackets. So my advice to you is let's do the part first. 4 squared times 4, that's like 4 to the power of 1. Yes, we add exponents in this case, because multiplying means you add exponents with the same base. 4 to the power of 2 plus 1 is 3. Okay? Now, ladies and gents, please do not do the following for this part in green. Do not go, oh, 4 divided by 2, that's 2. 3 minus 6, negative 3. That is not correct math. Once again, we cannot simplify into one power if the bases are different. So in this case, all we can do is just evaluate. We will take 3 cubed and find the number. 3 times 3 times 3. That's 27. We'll take 3 squared, find the number. That's 9. And then over here now with the 4 cubed, all we can do is just find the number. So 4 cubed, 4 times 4 times 4, that's 64. And then 2 to the power of 6. We'll use our calculator if you're not too sure, but that just seems to be, oh, also 64. How convenient. Because what's 64 divided by 64? Yeah, it's 1. So that just simplifies to the following. And now we can evaluate 27 minus 9. That's 18 plus 1, 19. Okay. Please, please remind yourself, when it comes to adding and subtracting exponents on the same basis, there is no special rule. So that's like this thing right here, okay? I'll put this in purple. See, no rule for that. No rule for this. Just evaluate using order of operations.